Well, if you saw my screencast on differentiating the natural log function, you learned that the derivative of the natural log of x is just 1 over x. So reversing that, that means that the integral of 1 over x dx is the natural log of the absolute value of x plus c. And the reason we have to have an absolute value in there is because we can only take logs of positive terms. So people often ask, well, why can't we just use the power rule? And here's why. If I rewrite the integral of 1 over x dx as the integral of x to the negative 1 dx and try to apply the power rule, that means I add 1 in the exponent and I get x to the 0, and I divide by that number, and uh-oh, now you see why we can't do it, because you're never supposed to divide by 0. So just remember that the integral of 1 over x dx is the natural log of the absolute value of x plus c. So let's see how we can apply this new rule. Well, if we'd like to find the area of the region bounded by the graph of y equals x over x squared plus 1, which is this red function here, the x-axis, and the line x equals 3, so that's this area right here, more or less, then we're going to integrate that to find the area. So I'm going to go from 0 to 3 of x over x squared plus 1 dx, and we can do a u du substitution. We'll let u equal the denominator, which means du is 2x dx. So I'm going to have 1/2 my integral, and then since I've divided by 2 outside, I can multiply by 2 inside. Okay, so remember that all of this now is du, and all of this is u. So in terms of u, this is 1/2 the integral of du over u, which is 1/2 the natural log of u. Okay, so let's rewrite that now in terms of x. So we're going to have 1/2 the natural log of the absolute value of x squared plus 1 from 0 to 3. And when you think about it, I don't even need that absolute value anymore, because x squared plus 1 is always going to be positive, isn't it? So we'll just put parentheses around that, okay? All right, so I've got 1/2 the natural log of 3 squared plus 1, so that's natural log of 10, minus 1/2 the natural log of 0 squared plus 1, so that's the natural log of 1, which is 0. So our final answer is the natural log of the square root of 10, because that 1/2 can come around front and be the exponent of 10. Now, something to watch out for. If the degree of the numerator is greater than or equal to the degree of the denominator, divide the rational expression first. And that's the situation we have here. We have a second degree numerator and a first degree denominator. So I'm going to divide x plus 1 into my numerator. And so x times x gives me x squared. X times 1 gives me x. When I subtract, I get negative 3x minus x. Bring down the 2. I need to multiply that x by negative 4. Negative 4 times x is negative 4x, and negative 4 times 1 is negative 4. When I subtract that, I get 2 minus negative 4, which is 6. So we can rewrite our integral as the integral of x minus 4 dx plus the integral of the remainder, which is 6 over x plus 1 dx. Okay, so I split that fraction into the quotient plus the remainder. All right, so the integral of x minus 4 is 1/2 x squared minus 4x. And here we'll do a u du substitution. U will equal x plus 1. Du is dx. And so I can rewrite that as 6 times the integral of 1 over u du. And that antiderivative is 6 natural log of u plus c. Okay, so now we put everything back in terms of x. I have x squared over 2 minus 4x plus 6 times the natural log of the absolute value of x plus 1 plus c. And that's our answer. One more example. You can even use natural logs when you're dealing with antiderivatives of trig functions. What would happen if I rewrote tangent? Now that's ugly, isn't it? Let's rewrite tangent as sine of x over cosine of x dx. We'll let u equal the denominator. So du is negative sine x dx. So I'm going to multiply inside by negative and outside by negative to keep everything balanced. And I'm going to have the negative integral of 1 over u du, which is the negative natural log of the absolute value of u plus c. Rewriting this in terms of x, I get negative natural log of the absolute value of cosine x, because remember we defined u to be cosine x, plus c. And if you really want to get tricky, you can take that negative 1 in front of the log and make it the exponent of cosine, and you could write that as the positive log of the secant of x plus c. All right, that's how you use natural logs when you're integrating.